Hi, my name's Ollie. I'm an Autodesk certified instructor, and today I'm going to be talking through 5 different ways to use the automated modeling tool that you hadn't thought of before. Now, we've probably all seen the automated modeling tool. It's up in the top in our default toolbar, and you might have hovered over it and seen what it does. You may have even tried to use it. Now, there is the standard use of the automated modeling tool, which allows you to create volume between multiple items. For example, here I've got these 3 parts of a motorcycle and I want to join them together. I can select those faces, I could assign bodies to avoid if I need to, and I can generate shapes. And what that's going to do is it's going to give me various different alternative shapes that I could use to join these parts together. In a lot of ways, it's a precursor to generative design, and it's absolutely brilliant for doing something like this and creating shapes quickly. Now, I'm not going to spend this video explaining how this tool works or how to use it. We have another video on that you can go check out, and I'll put it in the description down below. But in this video, I'm going to take it one step further than what you're seeing on the screen. We're going to look at not just the standard use of automated modeling to join parts together, but we're going to look at 5 different ways that you can use this tool in out-of-the-box thinking methods, in ways that aren't just joining parts together, but that are going to simplify your workflows, make your life a lot easier, and reduce the amount of work you have to do to get to an end result. So let's get straight into the first way you can use automated modeling that you hadn't thought of. In this case, I have a pedal assembly. Now, I've been working very closely with my colleague Alex, and I have been designing and manufacturing all of the mechanical components of this pedal assembly. But Alex has been designing the actual pedal itself because she has the CNC equipment to be able to manufacture it. Now, unfortunately, whilst I was working on this, Alex was reprioritized on another job. So she hasn't had a chance to actually create this pedal design. Now, I don't want that to hold up my design process and testing. Now, in a lot of top-down modeling situations, this might be called a primitive, where you would create a very basic shape that gives a rough outline of what the shape would be so that you can progress with the design. Now, often primitives are just boxes or cylinders to give a rough area that the design must fit within to fit within assemblies. But we can go one step further with automated modeling. Using the automated modeling tool reduces the amount of work that I have to do to create this primitive. It also provides a primitive that is a lot more accurate to what it's likely to be in the end. I can select the faces that I want to connect, being down at the bottom, this cylinder at the top, the pedal, and the joining clip at the back. I can say that I don't want it to interact with the mechanical components that I have added for my part of the design, and it's going to give me a variety of alternative options that I could look at. This does not mean that it's going to be the perfect design, but I could take that design and I could use it to design around. I could also, if I wanted to, go off and 3D print or manufacture that design to have a physical prototype to test that my mechanical components are working correctly. Finally, it also gives Alex a starting design that she can start working from. It can help us to collaborate together and make sure all our parts work in unison in our assembly. And it can give her a starting point to reduce the amount of work that she has to do in coming up with design options. Now, for our second use of automated modeling, Alex has come back onto the project. She wants to create an organic shape that's going to be free-flowing and low mass. And the way she's going to do that is with free-form modeling. This is going to give her the flexibility to give a nice organic shape that follows the curvature that she wants. But the problem with freeform modeling is that whenever you do it, you have to start from one of these very basic shapes. And to actually get anywhere near the shape that you want to be can take a lot of time. The good news is that automated modeling can be used to come up with the design conceptualization and allow you to work only from that point. So I have gone through and created this automated model that Alex can go and use. And if I was to go down to the timeline, I can edit the form of that automated model. When I go in and edit that form, I get all of the usual form tools, but I don't have to start from scratch. I can start from something that's already quite close to what I want. Now, that doesn't mean I wouldn't want to edit it. We know that we wanted a nice curve in this pedal. So I could, for example, go through and select some of the faces, modify them, go through and use some of the available tools to say that actually I want to edit this and soft modify it into a curved shape. Now that's going to give me the pedal shape that I want and make sure that it doesn't interfere with the foot that's using the pedal. But to get to that point has been a lot less work than if I'd have had to model that entire shape myself. So the use of automated modeling can be great for design conceptualization, where instead of spending your time manipulating very basic shapes that you have to start with, you can start with a more complex model that you can improve upon and focus your time on making it as good as possible. For our third way to use automated modeling, we're going to turn to generative design. Now, generative design is a great tool to come up with some really optimized designs, but sometimes it can be a little bit overwhelming, especially when it gives you 30 different design options that all have crazy different shapes. Now, in our case here, Alex has figured out that this is the rough shape that she wants. We know roughly what we're looking for, but we only want to optimize the design for mass. This is where a starting shape can be really useful in generative design. When I go through and I assign all of the information, as I already have done for my load cases and my obstacle geometry and preserve geometry, I can also go through and I can add a starting shape. The idea of a starting shape is that it will take that shape and build from it. When you're adding your starting shape, you can select your body from your automated model, and then you can select whether to either add or remove material, where it can do both, or in this case, we could just say that we want it to remove material from our existing design. When we do this, it'll go yellow, and we can then run our generative design study, and the result we'll get back will be the same design that we have put in, but only optimizing for mass and removing unnecessary material. Now, whilst this does reduce the creative production of generative design can't account for everything. So sometimes you need to apply your own design decisions and allow it to only optimize what you want it to, reducing the amount of time that you have to spend sifting through different design iterations that the tool gives you. Now, if I look at two different outcomes, one on the left with our starting shape and the one on the right without our starting shape, both are perfectly valid designs, but we can see how the one on the left follows the shape and the aesthetic of what we were going for with that curved shape. But you can see how automated modeling and using a shape generated with automated modeling as your starting shape is going to help you get to a more optimized design within the parameters that you're looking for in a shorter amount of time. Don't forget, it's also going to reduce the amount of time that generative design takes to actually create your various outcomes, because it only has to start from your starting shape, not from scratch. So that's an additional advantage as well. For our fourth use of automated modeling, we're going to move away from our pedal assembly and into a PCB. This topic is all around tooling. And the idea of tooling is that it is a part that helps you make your actual part rather than being the final result itself. Now, I'm using a PCB in this case, but there are hundreds of different examples across various different industries where this works. But what we have is we have in my assembly a PCB and a number of components that need to be soldered into that PCB. Now, the issue is that all of these components go into my PCB and then I have to turn it over and solder them all together. Now, I don't want to do these one at a time because it's continually flipping over my part. It has potential risk to get damaged. What I want is that all my parts can be put in, held in place. I can then turn over the PCB and hold it with a clamp or some other tool so that then I can efficiently and safely solder all of the parts in with the quality that I'm looking for. And this is an example where we can create a tool that could be used in the manufacturing or assembly process to help you with this. Now, in my case, what I've done is I've created an automated model. I've told it all the various faces of those parts, as well as telling it all of the other components that it needs to avoid that are already on the PCB. It is then generating for me a number of different alternatives, and from all of those alternatives, I can select one, and it's going to generate a shape that I could go off and manufacture, and it could just be, I don't know, plastic with a 3D printer, and that could go be manufactured as a tool that I can use to hold all these parts in place. Now what it's done is it's generated this shape for me. So if I remove the actual PCB itself, I can see that down below I have slots for all of the different components that I needed to fit in that fit exactly to them, whilst also avoiding all of the other parts in my PCB that would stop it from sitting in place. Now, of course, I could just model this manually using standard sketching and extruding and all the rest of it, but that would actually take a lot more time and it'd be a lot harder to fit all of the components together and make sure that they don't intersect with the part that I'm making. Now, of course, that doesn't mean I couldn't edit this. I could go through and I could add parts onto my automated model or model beforehand and include those as faces, such as a snap fit that attaches to the board or something that goes through one of the holes so that I can attach it. Making sure that the part I've automatically modeled is held in place as a single component I've got to hold rather than the 6 or 7 different components on the PCB. It's also a part that we can iterate on. If we were to go through and change our PCB design using Fusion's parametric tools and the design timeline, this automated model would automatically update with it. So if components move on my PCB or something new gets added, I can really easily and quickly update my tool to make sure that that cover still works for the assembly. The ability for automated modeling to fit to an existing shape is one of its best features, and that's what we're going to use it for in the final use of automated modeling that we're going to go through in this video. In this example, I've got half of a mold that is used in an injection molding process, and this mold was very carefully machined to an incredibly high tolerance. In this case, we can use it to create a shape that fits to our mold. It can then generate shapes that are going to fit inside that space, and we could manufacture them out of plastic or whatever process we chose to. This means that when we go out and place it on the shelf, we could place this automated modeling shape inside of the mold, and that's going to do a couple of things. It's going to help protect the mold from any knocks or scrapes as people use other parts on the shelf. It's going to protect it from dust or any other contaminants getting onto the mold. And ultimately, it could even be used to help identify the mold, because you could color code the various different inserts in different ways. Now, of course, you could just design yourself a cover to go over the top. But when automated modeling is such an efficient tool, it takes just a couple of seconds to go through, select your faces and press generate. Now again, this can apply to any different context. You could need to protect anything. You could create a surrounding case for a part. It could be a mold. It could be the tools that you use in your machine to hold the various tools and ensure that the sharp parts of them can't cut somebody. Ultimately, this is going to do the same thing as many of the other uses that we've talked about, which is saving time and generating a result that you know is going to work for your design and can easily be updated if your design changes as well. So there you have it, 5 different ways that you can use automated modeling that you might not have thought of. Hopefully this has given you an idea of some of the different ways you could apply this tool. If you've used automated modeling in a different way, or you've taken one of these 5 tips and applied it to your own situation, we'd love to hear about it. Put them down in the comments so that everybody else can see the way that you're using it. As always, if you've liked the video, press the like button down below. Make sure you subscribe for any of the other videos that we have coming out, and I will see you in the next video.